Hello students, welcome to Eshwari Thaniksha channel. In this video, we are going to learn a super trick to find the limiting reagent in the given reaction. For example, if you take A plus B giving C. So in this reaction, we have to consider only the reactants. So here the reactants are A and B. So if the quantities are not are taken in different amount and if it is not according to the balanced chemical equation, one can be the limiting reagent. So either A or B will be the limiting reagent. So suppose if B is taken in small quantity. So I'll write this B if it is taken in small quantity or least amount. So whichever reactant is taken in least amount, that is called as the limiting reagent. So this B will be the limiting reagent. So now what is the trick to find whether the limiting reagent is present or not? So we are going to see the trick now. So the trick here will be, so use this trick. So the trick what we are going to use is, if SR and MR, if this is same, then you can say that limiting reagent is absent, or you can say no limiting reagent. No limiting reagent in this case. Suppose if SR and MR are different, then you can say that limiting reagent will be present in this case. LR is the short form for the limiting reagent. So what is this SR and MR? So I'll tell you what is SR and MR. So here SR is nothing but stoichiometric ratio. Stoichiometric ratio. And MR is nothing but mole ratio. So now if stoichiometric ratio and mole ratio are same, then you can say that in that equation there is no limiting reagent. Suppose if both are different, stoichiometric ratio and mole ratio are different, then we can say that limiting reagent is present. So this is the trick we are going to use to find the limiting reagent. So let me take one example so to make you to understand about this. So now let me take equation. So first equation I'll take A plus B giving, or A plus 2B giving AB2. Second equation also I'll take same, A plus 2B giving AB2. So now first what we are going to do is, let us consider first equation. So in this let us consider SR. What is SR? SR, stoichiometric ratio. So here the stoichiometric ratio is 1:2. So stoichiometric ratio meaning is the number which is present here, adjacent number. So A, the adjacent number here. So if there is no number here, it means that 1 is present. So I have written here 1. And for B, the number which is present here will be 2. So I'll be writing here 2. So the ratio is 1:2. Next we will write mole ratio. So I'll write mole ratio. So from the information about mole ratio where you will get, so this will be given in the question. Suppose for example, if mole ratio is given as 4:8. So now tell me whether the stoichiometric ratio and mole ratio is same or different. So here it is same. So how do you say that it is same? So here what you should do is, multiply this number with any common number. So if I multiply with 2, what you will get? You will get into 2 means 2 ones are 2, and here if I multiply with 2, you will be getting 4. So ratio you will be getting as 2:4. So now I'll multiply with 4. So if I multiply with 4, how much you will get? Suppose SR ratio is 1:2. So now I'll multiply this with 4. If I multiply with 4, what you will get? You will be getting 4:8. Correct. See now, this ratio and this ratio, it is same. So multiply with some common number so that you have to get this ratio. So we are getting, when you multiply with 4, multiply this with 4. So you will be getting 1 4s are 4 and 2 4s are 8. So therefore we say that SR and MR are same. So when both are same, so see the trick here. When both are same, then we say that there is no limiting reagent in the given equation. So therefore I'll write here, there is no LR. LR meaning is limiting reagent. So there is no limiting reagent. Both the reactants will get completely consumed during the reaction. So both will get consumed and they will be converted into product. That is the meaning. So now second case we will take now. So second case, SR, stoichiometric ratio, it will be the same, 1:2. So now I'll take MR. So MR here I'll take it as 2:1000. So this will be given in the question, 2:1000. So now whether the SR and MR are same or different, here it is different. How you say that it is different? Because you multiply the ratio with any common number. See whether you will get 2:1000. Suppose if I multiply this with 5, what you will get? 1 5s are, you will be getting 5. 2 5s are, you will get 10. So you will not get this ratio. Suppose if I multiply with 1000, so 2 into 1 into 1000, I'll get 1000 is 2. 2 into 1000, I'll get 2000. So 1000 is to 2000. Suppose if I multiply this into 500, how much I'll get? 500 is to this. If I multiply with 500, I'll get 1000. So with some common number, if I multiply, I'll get 500 is to 1000, but you will not get 2:1000 if you are multiplying with some common number. Therefore, SR and MR are different here. So if it is different, then limiting reagent will be present. So I'll write here, limiting reagent is present. And which is the limiting reagent here? So the one which is in small quantity, here A is taken in smaller quantity. So A will be the limiting reagent. So whichever is taken in small quantity, that will be the limiting reagent. So this is how we find whether limiting reagent is present or not in the given equation. So let us take some more example to understand this. So the first example what I am taking is aluminium reacting with oxygen to form aluminium oxide. Number of moles of aluminium in the question, it is given as 8, and for oxygen it is given as 6. So now we will find SR first. So SR is nothing but stoichiometric ratio. So here it is 4 and 3. So 4:3. 4:3. Next I'll write mole ratio. So mole ratio, this is given in the question, 8:6. So I'll write here 8:6. So whether it is same or different, so here it is same. SR and MR are same. Why? Because if I multiply this with 2, what you will get? 4 2s are 8. 3 2s are 6. So I am getting mole ratio. So multiply this with some common number. So 4:3 multiply with 2. So if I multiply with 2, I'll get 8:6. Therefore, SR and MR ratio are same. So if it is same, what is the trick we have written here? If it is same, then there is no limiting reagent in the given equation. So I'll write here, there is no LR. LR means limiting reagent. So there is no limiting reagent. Meaning is both are taken in equal quantity and both are consumed during the reaction. That is the meaning. So let us take one more example. So this is another example. So here see the question. Nitrogen reacting with hydrogen to form ammonia. So here in the question it is given nitrogen, the number of moles is 12, and for hydrogen it is 12 moles. So you have to check whether limiting reagent is present or not. So let us check now. So SR is 1:3, correct? Next find MR. Next is MR, mole ratio. So mole ratio, it is given in the question 12 and 12. So it becomes 12:12. So I'll write here 12:12. So now whether the ratio is same or different. So here it is different. Why? The ratio is not same, it is different because here you can see 1:3. If I multiply with some number, suppose if I multiply with 2, what you will get? 1 2s are 2, 3 2s are 6 I'll get. Suppose if I multiply with 3, 1 3s are 3, 3 3s are 9. So I'll get 3:9. If I multiply with 4, 1 4s are 4, 3 4s are 12, 4:12. So I'll be getting 4:12, but I'll not get 12:12 as the ratio. So therefore you can say the ratio will be different. If it is different, then we can say that LR is present. That is, limiting reagent is present. Meaning is one is taken in excess quantity and one is taken in smaller quantity. So now we said that limiting reagent is present. Now next is we have to find which is the limiting reagent, whether nitrogen is the limiting reagent or hydrogen is the limiting reagent. So for that we have a method to find. So what is that method is? So equation nitrogen and you have hydrogen 3 times H2. So what you have to do is, first step you have to write the number of moles. N is called as number of moles. So N for nitrogen it is given in the question as 12. For hydrogen also it is given in the question as 12. So what is N? N I'll write here, it is number of moles. Second step is stoichiometric coefficient you have to find. SC. So SC is stoichiometric coefficient. So here stoichiometric coefficient. So stoichiometric coefficient is nothing but the number which is present with the atom or molecule. So here nitrogen 1 and hydrogen is 3. So I'll write here 1 and 3. So next step is what you have to do is divide the number of moles divided by stoichiometric coefficient. So for nitrogen 12 by 1. For hydrogen 12 by 3. So if you divide, how much you will get? Here you will be getting 12 and here you will be getting 4. So here 12 and here 4. So for nitrogen you are getting 12 and for hydrogen you are getting 4. So whichever you are getting in smaller number, whichever is small, so that will be the limiting reagent. So 4 is small number, so 4 you are getting for hydrogen. Therefore here you can see hydrogen, since it is present in small quantity, hydrogen is the limiting reagent, LR. Is that clear? So students, here you have to find which is the smallest number. For nitrogen we are getting 12 and for hydrogen we are getting 4. So whichever is in smaller number, so that will become the limiting reagent. For hydrogen we are getting 4. So hydrogen becomes the limiting reagent. So this is how we find whether limiting reagent is present in the given equation. If it is present, this is the method we use to find the limiting reagent. So students, I hope it is clear to you. So students, if you are new to our channel, subscribe our channel and also share this video with your friends. I'll meet you in the next video, students. All the very best.